Hey y'all, we're going to talk about rational exponents today. So this whole time we have been talking about radicals and we haven't really talked about an exponent. And so in this lesson today we're going to talk about how you can rewrite radicals as a form of an exponent. So the first question here, it didn't copy over. How are the square root of 16 and 16 to the 1/2 power related? Well, if you type them in your calculator, they are the same. They are, in fact, equal to each other. The square root of 16 is the same as saying 16 to the 1/2 power. And this rule applies for any radical that you use. So, for example, if you have the square root of 36, I know this is hard to see, so I'm going to rewrite it. If you have the square root of 36, that's the same as 36 to the 1/2 power. If you have the cube root of 64, that's saying 64 to the 1/3 power. And if you have the fourth root of 16, it would be the same as saying 16 to the 1/4 power. Okay? So, the key thing here to pick up on is your index is the denominator of the exponent. Now, your next question might be, where did that 1 come from? This is 36 to the 1st power. This is 64 to the 1st power. This is 16 to the 1st power. So, whatever power you have in your radicand, that is your numerator. And we'll look at that more in just a bit. So on problem number 1, they want us to rewrite and they want us to simplify. So if I have 216 to the 1/3 power, that's the same as saying the cube root of 216. And we can type that in our calculator. And we're going to say the cube root of 216 is 6. So that whole expression would simplify to 6. Same thing here. We have 7 to the 1/2 power times 7 to the 1/2 power. That's the square root of 7 times the square root of 7, which equals the square root of 49, which is, in fact, 7. On this bottom one here, we have the fourth root of 5 times the fourth root of 125. And going back to our last section, a couple sections ago, over multiplication, as long as they have the same index, we can multiply those together. So that gives me the fourth root of 625, which I think gives me 25, or maybe 5. Let's check. So we're going to type in a 4 and go to math. And we're going to go to option number 5 and type in 625. And it gives me 5. Yep, perfect. So just getting comfortable with that relationship of the two going back and forth. And if you want to practice that here, we encourage you to do so. That's the square root of 64, which is 8. This would give you the square root of 11 times the square root of 11, which equals the square root of 121, which is in fact 11. And on this last one, that would give you the square root of 3 times the square root of 12. That's the same index, so I can multiply those together to give me the square root of 36, which is in fact 6. So, knowing that relationship, that if you have the nth root of x, that's just x to the 1 over n, a really important rule follows from that, such as the nth root of x to the m. Okay, so let's say you have a power underneath that radical. You can write that a couple of different ways. Mainly, the two ways that we see them would be like this or like this. Okay, so most importantly, probably what's in this box right here, this is going to make the most sense. Okay, if you have, for example, let's say we have the fourth root of x to the 5th, That's the same as saying x to the 5/4. That's also the same as saying x to the 5th, and then that's raised to the 1/4 power. Those all mean the same thing. Excuse me. So, important note down here at the bottom. When we are given an expression with a fraction as an exponent, we need to write it as a radical, okay? So, we are always going to have to float in between these two forms in order to give you a simplified answer. So, let's just go ahead and jump on in with problem number 2 here. It says, what are the square root of a to the 5th and the 5th root of b cubed in exponential form? Well, if it helps you, again, remember that if there's no index number, it's a 2. So that would be rewritten as a to the 5/2 power. And then for the b one here, again, the index is your denominator, so that would be b to the 3/5 power. Regardless of whether your exponent is outside the parentheses or inside the parentheses, that's always going to be your numerator. And then same thing for down here at the bottom. This would give us x to the 3/4. And then this one would give us y to the 4/5. Again, your index is your denominator, and then your power is your numerator. So let's kick this up a little bit, and then this could be the end of part 1. So on problem number 2, continued. This is going to get a little bit harder because especially this one right here, that looks a little scary. But let's wait 2 seconds. What is x to the 3/7 in radical form? X to the 3/7 would be the same as the 7th root of x cubed. You could also write that as the 7th root of x, and then in parentheses, you could put your cubed on the outside. Either one is acceptable. I typically go with the top one. All right, let's get to this beast here. We have y to the negative 3.5. Okay, if we ever have a negative exponent, remember we got to move that to the denominator. And I don't like having decimals. That's kind of throwing me off. So let's change that to a fraction. 3.5 is the same as 7/2. So that gives us 1 over the square root of y to the 7th. Let's clean that up and simplify that a little bit. Let me come over here. That would give us 1 over, let's simplify here, 2 goes into 7 3 times with 1 left over. And this goes back to what we did in 6.2. I'm going to have to rationalize here because I can't have a radical in my denominator. So that gives me the square root of y all over y cubed times the square root of y squared, which is just y. So that would give me the square root of y over y to the 4th. Again, I can't cancel out those y's because one of them is under a radical. All right, with that same topic, let's try these at the bottom. I have w to the negative 5/8. So again, let's go ahead and change that to w on the bottom. And let's see here. We're going to rewrite that as a radical. So we would say 8 root of w to the 5th. And I can't leave that there. I'm going to need a total of 8 w's to get rid of that radical. I already have 5. I need 3 more. So that would give me the 8th root of w to the 3rd all over w. Because this right here would give me the 8th root of w to the 8th, which is just w. And there we are, simplified there. And then on the second one, we have w to the 0.2, which is w to the 1/5. If I change that decimal to a fraction, which is the 5th root of w. Man, that one was easy compared to that last one. If you need a recap here, we would be more than happy answer any questions that you have. But in the second part of this video, this is where it gets a little bit harder. So go ahead, and if you're ready, you can go ahead and do part 2.